Okay, problem 7-32 goes over a good process for setting up a word problem. First, you draw a diagram. Then you name and define the different variables. Then you write and simplify equations. Identify the variable that represents the quantity needed. That means basically figure out what is the question. And then fifth, write the variable you need in terms of one of the other variables. Basically getting one of your variables alone. And then finally graph the situation so that you can find the answer. Graphing with a graphing calculator is frequently a really good way to solve a large problem like this. So let's get started. We're looking for the volume of an open top rectangular box that is 4,500 cubic centimeters. The length of the box is twice the width. Find the height so that the surface area is as small as possible. So we're dealing with an open box. I'm going to sketch a box. There we go. Next, name and define the different variables involved. It's suggesting that we use x, h, and s. So let's call x our width, and right here it says that the length is twice the width, so I know that the length is going to be 2x, and height h. So we've got h represents our height. X is our width. So 2x is our length. And we're going to call S our surface area. And we know that our volume is 4,500 cubic centimeters. Okay, third step, write and simplify equations that relate to the different variables. Let's go ahead and write an equation for volume and an equation for surface area. So surface area in this case is going to be the area of the front and the back, which are each the same. So the area here is going to be x times h, and I've got one here and one back there in the back. So I've got 2xh. That added to this side area and the other side that matches it. So that's 2x times h, so 2xh, and I've got the other one on the other side, so 2xh and 2xh, that makes 4xh. And then the area of the bottom that matches the same as the area of the top. Can't really see it. It's the area of the bottom. 2x times x, so 2x squared. We can simplify this because these are like terms, and I'll put my squared first. I've got 2x squared plus 6xh. And we also want to write an equation for the volume. My volume is 4,500. And to calculate volume of a box, it's length times width times height. So here we go. Length, 2x times width, x times height. So 2x times x times height, it's going to be 2x squared h. And now I've got my two equations. So let's go step 4. Fourth, identify the variable that represents the quantity needed to answer the question. Well, let's look at the question. Find the height so that the surface area is as small as possible. So what are we trying to get to be as small as possible? The surface area. We're trying to minimize the surface area, and we want to find the height that makes that so. So let's find surface area. So we're going to take this equation and we need to write it in terms of only one variable. To be able to do that, I'm going to, oops, I wanted it to be this one. That's the more simplified one. I need to substitute these two equations together to do that. So let's solve this one for h and substitute. So if I divide both sides by 2x squared, get that the height is equal to, oh, what's that? 1, 2, 3, nope. 2250. Over x squared. So let's substitute that in for the h right here. And rewrite. So I've got s equals 2x squared plus 6x times 2250 over x squared. Okay, let's simplify a bit. This x divided by one of these x's, and then 6 times the 2250, that leaves 2x squared plus 13,500 over x. Now let's graph what we've got here. So I'm going to pull up graphing calculator. Here we go. So we're going to put in our 2x squared plus 13,500. I'll make sure that it does order of operations correctly, so I'm going to put a parentheses around it. Divided by x. And press enter to graph. Alright, I don't see anything at this point because my window is not very conducive to this problem. So let's press menu and change the window. So window settings. I'm going to go ahead and tell it directly. My x represents my links. So what kind of window do we need here? Do I have a negative length? Nope. So let's go ahead and start with 0 for my x minimum. My x maximum, I'm not quite sure what it's going to be, so let's go ahead and just put in 25 because we're looking at length of a box. For my y minimum, are we going to have a negative surface area? Nope. So let's call that 0. And let's see, my volume is 4,500, so let's go ahead and put in 5,000 just to make sure we get a large enough value to represent the surface area. Okay. Oh, we can see the curve. Alright, so let's use the trace function, and we want to get to the minimum, the smallest value of surface area as possible. So I'm going to trace my graph, and using my arrows back and forth, I want to get to where it's the smallest value of y, the smallest value surface area possible. Oh, we got to 1350. If I keep going further to the right, it starts increasing again. If I go back further to the left, we get down to 15. That seems to be the minimum, and it starts increasing again. So I'm pretty sure my solution here, my minimum, is at 15 and 1350. So let's write it down and work with that. Okay, 15 and 1350 was the point. Oops, 1350 is the point that we got, where S is the output. So S, surface area is 1350, and my input was X. So this is 15. So if this is 15, I know on my box here I've got that this is 30. And I'm looking for what is my height when my surface area is 1350. So 1350 equals 15 times 30 times height. Let's divide both sides by 15 times 30. And height is 10. And this seems to be all in centimeters, so my height is 10 centimeters. So, did we answer the question? Find the height so that the surface area is as small as possible. Our minimum surface area was 1,350 square centimeters, and at that surface area, our height is 10 centimeters. So at the height of 10 centimeters, we have the smallest surface area possible. All right, next we're going to put these steps to use solving the next problem. See you in the next video.